Right, good morning, Jay. This section is a little bit weird if it doesn't get related back to what we've already done. So I'm going to relate it back to what you know already, and then I'm going to try to pick an example problem from each section from the book to just do one. So if I need my calculator, I'm going to have to run and get my phone or something. We'll see. But this is 8.2, and really what it's about is it's about trig numbers, all right? Or numbers in trigonometric form is what they call them. But let's relate it back to vectors a little bit, because essentially what this section is about is it's all about what they're going to call standard form. And standard form is something like 6 plus 7i, okay? And that's really, standard form is like a complex number. All right, so just something with an I in it, and you did a bunch of stuff with I's in Algebra 2. But essentially what this is really, in a way, this is kind of what I'm going to call vector form, all right? Like, literally what's very interesting is this is the exact same thing as this from last chapter when we had the vector 6, 7. And if we would, like, literally draw 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, put a point there, and this would be the point 6 plus 7i. We wouldn't draw the arrow to it, but it'd be that point, right? And that's because they are graphing things on like a real and an I-axis. Like, you may even remember doing that slightly in Algebra 2, but we didn't do that very much. So literally, standard form is just kind of like a vector, or graphing it in like an XY chart, but it's just real and I's. Whereas trig form, that's one of the reasons that I actually had you start with 8.5. Part of it was just because it was easier in case I was going to have to bring the rest of the trig class into this. But this is honestly like polar coordinates, which you were doing really, really good with because you had read 8.5 and turned it into different things like that. So trig form is really when, because you remember how polar coordinates, it's kind of like polar form. Polar is where you had something like 3, 45 degrees, right? And this would be like the radius, and this would be the degree, right? That it would go out. Really, that's what trig form is. It's very weird, though, if you're wondering like how they get there. They write it, all right, like, well, they write it two different ways. The shorthand form, which I prefer, all right, shorthand form, would be 3 cis 45 degrees. And cis stands for cosine and then imaginary sine. All right, that's because, but really all you need to know is that this point right here would be the kind of the polar point, 3, 45. So literally it would just be, you'd go out 3, a radius of 3, and 45 degrees. So this is kind of like your radius, and this is obviously your angle on the unit circle. Now, longhand, if you want to know longhand, how they're writing those is they're literally, I know this is crazy, but they put the radius out front, and then they write cosine 45 plus I sine 45. And you might be wondering, why did they do that? Like, why is there shorthand, longhand, what's standard, what is going on? Well, it's because, all right, think about this. All right, if this is a 45 degree triangle, now this is going to get really ugly because I did not use a very good number. Let's change it for a second. I'm going to apologize. I'm going to use 4 because I think that's going to be a little bit nicer. All right, if we had this triangle, we could find the sides of this triangle because this would be some root 2. So I think this would be 2 root 2, 2 root 2, I think. And how we'd have to do that is we'd have to set up our 45, 90, and do 1, 1, root 2, right? And do our ratio of root 2 over 4 would equal, I know I'm getting really small over here. Maybe I should like zoom in or something. Now I don't even know if that's in the screen. Hopefully that's in the screen. Sorry. But do root 2 over 4 equals 1 over x. But then we'd have root 2x equals 4. Divide by root 2. Get the root 2 out of the bottom. Yeah, 2 root 2. So this would be that triangle. So this point would actually be the point 2 root 2 comma 2 root 2 if we were writing it as a point. Or in standard form over here, it'd be 2 root 2 plus 2 root 2i. Okay? But believe it or not, check this out. Cosine of 45 is root 2 over 2, right? You just know that from the unit circle. And sine is root 2 over 2i. Or is root 2 over 2. And if we have the I in there, if we distributed this, 4, the 2 would cancel and reduce with the 4. We'd have 2 root 2 plus 2 root 2i. So actually what longhand does is longhand, I'm going to make sure everything's still on the screen while I'm talking to you. Longhand actually just, yeah, it is, okay, good. Basically shows you that if you would distribute and actually put everything out, it would be the exact same thing as the standard form over there. All right, so that might be a lot to take in right now, that's fair. But actually what's really, really nice is if you kind of still relate it all back to vectors, it really makes sense, okay? Because what you really just need to know is that any point you draw, which is going to come from standard form, even though we don't draw a vector anymore, you can always think of there being a radius or the hypotenuse, and that's going to be the number that comes in front of the cis. And there's always going to be an angle to the x-axis, right? And that's always going to be the number that comes after the cis, okay? And I don't typically write things in the longhand form. The longhand is just to show you that it actually, if you distributed everything, if you found those on the unit circle and distributed the 4, it would be the exact same thing as standard form. All right, so now let's do a couple examples, but my guess is if we relate it back to vectors, that you're going to be okay. So I'll do one from each section and then call it good, but you can definitely still email with more questions. All right, don't hesitate. That's what I'm here for. Not a problem. Although I don't know what I did with my marker. That's the cost of asking for a video. Oh, it's right here in my book, obviously. Don't tell anyone I did that. Okay, so for instance, if it says here, like number 3, the directions are find the absolute value. I know this seems weird, but the absolute value of an imaginary number is actually the Pythagorean theorem. Like, so the absolute value, believe it or not, is actually asking for the like radius or the hypotenuse, quote unquote. All right. That's actually just definition of, like, that's what they defined it to be. There's not necessarily a reason for that. That's just what it is. So in this case, it'd be 1 squared plus 1 squared equals 2 and square root that. So the answer to number 3 is root 2. That does mean the answer like something like number 7, though, where it's just 2. Well, we actually know the absolute value of 2 is 2. But here it's because you take 2 squared plus 0 squared, because there's no i's, and get 4 and square root that, and you get 2. So literally what's kind of weird is any questions that you have to do between 1 and 10, it's actually just like the Pythagorean theorem. We should probably do something like the next section. So let's look at 17. So 17 wants you to graph, I think, graph each complex number along with its opposite and its conjugate. So that's just some good vocabulary here. 17 is just a good one, I think. So negative 5 minus 2i. Hopefully I'm not choosing all ones that you have to do, but I'm guessing you have to do evens. So this is the original. All right, and if I graph that, that's obviously just 1, 2, 3, 4, 5. 1, 2, boom. That's the original. Right, I'm going to do different colors so we can see what's going on here. So if I use blue, what's it say first? The opposite. Opposite is where you switch both sounds. So this would just be 5 plus 2i. And so 1, 2, 3, 4, 5, 2, boom. This is the opposite. And then I'll do in orange the conjugate. The conjugate, that looks very similar to that. Oh well. The conjugate is where you just change the sign on the I. Okay, so you're going to have negative 5 plus 2i. So this one would actually be right here. Okay, so that's that. So hopefully that's just some vocabulary there. But here's where we get into some good stuff, okay? Where it wants us to change numbers into standard form. So let me do like 21 and 25, and then I'll do one where you got to go the other way as well. And then I think you're going to be good to go. But like I said, if you got any more questions, let me know. 21 is 4 cosine 120 plus I sine 120. And I'll do 25 as well, because that's in shorthand form, 1 cis 315. So here's really what you have to remember. Even though this is ugly form, I mean, you could do this one of two ways. You could actually find cosine of 120, find sine of 120, and distribute the 4. Or, honestly, what I typically do is I typically just draw a triangle. I'll show you both ways. I typically draw 120 degrees and go, oh, here's 120 degrees, right? Which I know this is a 30, 60, 90, and they just told me that the radius or the hypotenuse was 4. As soon as I know that, I can set up like a ratio. Like I know on a 30, 60, 90 that half of the hypotenuse is this side, so that's 2, and this side is 2 root 3, right? So then boom, this side is -2 because it goes in this direction, and this side's up, but it's got an I on it because this is the I axis and this is the real axis, so I get -2 plus 2 root 3I. Now if you didn't want to do it that way, but you want to do it this way, you could say, oh, well, I'm just going to know from the unit circle that cosine of 120 is -1/2. And then there's an I on here, and I know that sine of 120 is root 3 over 2. And then you just distribute your 4. 4 times -1/2 is -2. 4 times this is the 4 and the 2 reduce and get 2 root 3I. So you can do it either way. The reason that sometimes I just do it the triangle way is because of something like this. Here, you'd have to rewrite it in long form to be able to distribute it, right? Here, I could just go, oh, 315 is right here. Boom. That's 315. If this is a radius of 1, should be a 1, 1, root 2. So this would be like root 2 over 2, root 2 over 2. This one's negative. And then you go, okay, so now this side's the real side, so it's root 2 over 2 minus root 2 over 2I, because this one goes down and it's the I. Now again, you could do it long form, right? You could just split this into 1 and then cosine 315 plus I sine 315. And you would know that cosine of 315 is root 2 over 2 from the unit circle. And then this is negative root 2 over 2 from the unit circle. And distributing the 1 doesn't make a difference, so you just clean that up, right? And you'd get root 2 over 2 minus root 2 over 2I. So that's kind of what goes on. And then I don't even know if I have you do any between 27 and 34. But if I did, that's where you can't draw a triangle that's a 30, 60, 90, or 45, 45, 90. So you'd actually just use your calculator. Like on number 27, you type in cosine of 12 and take it times 10 and get the decimal approximation for the first part that's real. And then take sine 12 and take it times 10 and you get plus that much I, right? So how about we do one where we go the other way? So one where we go the other way, let's do one that comes out as a decimal. So like we'll do number 49, but we'll do one that comes out even as well, like maybe number 37. So 37 and 49, and then we'll call it good. So now you've got to take this and write it in cis form. So I just basically put my cis down here. I'm going to go, okay, I got to fill in the angle, and I got to fill in the degree. And then 49 is 20 plus 21I. So this one's the easier one because it's a triangle that we know. They kind of split them up into sections of triangles we know and don't know. So 1 over 1, down 1, right? Because this is 1, -1. So this is essentially the point 1, -1, right? So boom, that's right there. And so if I know this is 1 and this is -1, I'm like, well, shoot, 1, 1, root 2. I know that, and I know what degree it is, right? It's 315. So this is just going to be root 2 because the hypotenuse is root 2, and this is going to be 315. Do note that proper cis form has to be between 0 and 360. So technically, even though this is correct, and like in polar form, you could have said like root 2 comma -45. In polar form, they let you have negatives wherever you want, but in cis form, they want everything to be positive. So they want this to be in between 0 and 360, and they want this to be a positive number. You're not going to have a negative radius on there. Okay, so hopefully that makes sense. And then here, same thing, but this is where you're going to have to do a little bit more work. You'd be like, oh, you got to go over 20, up 21. So this is 20, 21. We've got to find the angle and the radius. Well, how do we do those things? Well, first you have a calculator, which I don't have, because we have to use the Pythagorean theorem to get that, and then we'd have to do. I'll let you think about what we do while I type stuff in. How's that? I'm just gonna jump up here. I'm just gonna hop on Desmos. So 20 squared plus 21 squared is 841, and the square root of 841 is 29. Hey, that's a nice triangle. Cis 29. And so that is what the first thing in your cis is, because that's the radius. So cis, and then we've got to figure out the angle in decimal degrees. Now do notice in this section, it looks like everything so far is in degrees. Sometimes in other sections they're going to have you use radians, so like this would be 7 pi over 4, right? So just kind of be aware of that, but especially when you're using decimals. Now this is where from vectors this handy thing comes in. Do tan inverse every time, right? Do tan inverse of the y part over the x part, right? So tan inverse of 21 over 20. So I'll type that in really quick as well. Tan inverse of 21 over 20 is 46.4 degrees. So yeah, that hopefully helps with section 8.2. Let me give you a heads up on 8.3 and 8.4. But if you are like, man, that's still confusing, then I'll just make another video for them, and I'll probably combine them. Oh, never mind, I won't, because I thought 8.3 was products and 8.4 was quotients. Products and quotients are together, so I'll just do that one. Basically what's going on is you know how to multiply two of these numbers, right? If we took this times, I don't know, 3 plus 4i, you'd know how to FOIL and get rid of the I squared. That you were good at from last section. But if we changed both of these into their cis forms, we could actually multiply them as well. And there's a fancy trick to that. I think you're supposed to multiply the radiuses and add the angles. I'd have to look back in the book. But that's kind of what the next section is about, is how to do multiplication of trig numbers, so the things in cis form, and division of trig numbers, so things in cis form. But you can do them the long way or the short way, and it kind of wants you to kind of guide through both and see that. So if you need more help with 8.3, though, let me know. But hopefully that helps with 8.2, and let me know how it goes.